G'day viewers, in this episode we're going to walk through 4 simplified examples of how to manage cyber risk utilising testimation technology. However, before we embark upon this journey, we need to clarify what we mean by managing cyber risk. That is, we need to specify the context of our objective. Testimation technology is commercial off-the-shelf technology, and we utilise it to demonstrate how it may be applied to minimise the cyber threats associated with undefined requirements pertaining to contracts, litigation, acquisitions and procurement. Let's pause for a moment to consider why many legal disputes arise. Well, one reason why they materialise is due to undefined requirements. Undefined requirements introduce ambiguity, obscurity and uncertainty, etc. If legal documents could be written with the precision of a mathematical proof, ambiguity would evaporate and legal challenges would be substantially more difficult to initiate. Thus, orbiting a cyber risk management strategy around the cyber risk equation significantly evaporates the influence of ambiguity. As you can clearly see, the cyber risk equation eliminates all legal interpretations of cyber risk because it is a precise mathematical definition. Consequently, cyber threat minimization is achieved by precisely and unambiguously specifying the minimum level of cyber confidence to be delivered and the maximum level of cyber risk to be tolerated. We shall demonstrate, utilising 4 simplified examples, how testimation technology may be applied as a key delivery and decision-making tool with respect to contracts, litigation, acquisitions and procurement. Hence, as mentioned previously, by orbiting a cyber risk management strategy around the cyber risk equation, the impact of undefined requirements is minimised. Testimation technology is utilised to predict, measure, manage and mitigate cyber risk. It achieves this by determining the number of test cases required to quality assure software and expresses the result in terms of a probability distribution denoting cyber confidence. Testimation technology has been experimentally validated to greater than 98.07% accuracy, and all experimental results are available for peer review. Okay, that's enough chitty chat, let's get into it. The first thing we shall do is utilise testimation technology to build a decision assistance table. Many forms of decision assistance table may be constructed depending upon requirements. In this instance, we have specified a decision assistance table aligned with the needs of the 4 simplified examples we will be working through. The next thing we shall do is walk through the decision assistance table shown, and to save time, we will focus on its key features. Number 1. 8 quality assurance solutions are tabulated and associated with specific values of cyber confidence and cyber risk. Number 2. Each quality assurance solution has a certain number of test cases associated with it. The number of test cases are unimportant for the purposes of the decision assistance table. What is important is the linear scale from quality assurance solution 1 to quality assurance solution 8. For example, if the required number of test cases at Quality Assurance Solution 1 is 10, then the Quality Assurance Solution 8 requires 80. Similarly, if the cost of Quality Assurance Solution 1 is $10,000, then the cost of Quality Assurance Solution 8 is $80,000. Number 3. The economically optimal solution of 99% cyber confidence is emphasised by green cell shading. Number 4. Nomenclature. Cyber confidence equals defect-free confidence. This is the probability that an application or information technology system is void of defects. Cyber risk equals the testing not executed, which equals undiscovered defects. This is the probability that an application or information technology system contains dormant defects which have not yet been discovered. A test case is defined as a train of function points or user input commands following a functional process. User input commands are also known as user steps or test steps. Superoptimal test cases are tests which are designed, written and executed beyond the economically optimal solution of 99% cyber confidence. Typically, these take the form of negative test cases. Number 5. Description of test cases. Each quality assurance solution is composed of critical, high, moderate and low priority test cases. Please study the decision assistance table legend. Quality assurance solutions 5 to 8 incorporate superoptimal test cases. Plus 25% SO indicates that an additional 25% test cases are designed, written and executed which satisfy the superoptimal definition. Similarly for plus 50% SO, plus 75% SO and plus 100% SO. Okay, now that we have established the basics, let's define the scope of our simplified examples. An effective means by which to communicate the decision-making power of testimation technology is to investigate 4 simplified examples as follows. Number 1, a contractual situation with the Martian Department of Defence. Number 2, litigation against the National Bank of Mars. Number 3, Martian Capital Investments is seeking to acquire Virgin Interplanetary Airlines. Number 4, the United States of Mars is seeking to procure next-generation strike fighters for their war against the People's Republic of Venus. Okay, let's get into it. Our first simplified example involves 4 significant areas of consideration. That is, the contractual dilemma, the contractual requirement, the business requirement, and the investigation. Okay, let's walk through each area. Number 1, contractual dilemma. The Martian Department of Defence is seeking to improve the functional reliability of the software controlling its combat drones by introducing a strict contractual requirement for all third-party vendors. The contractual requirement is to be enforced by a quality assurance specification generated by Testimation technology. Number 2, contractual requirement. Third-party software development contractors shall deliver military combat systems to a functional reliability standard of no less than 99.97% defect-free confidence. Hence, the probability of undiscovered defects, that is, the cyber risk, should not exceed 0.03%. Number 3, business requirement. 10 functional processes relating to the operation of combat drones are required to be validated to 99.97% cyber confidence. Number 4, investigation. Measurements. The average number of user input commands per functional process is 5. Okay, now that we have outlined the challenge, let's tackle its resolution. The contractual dilemma calls for the utilisation of Testimation technology in order to enforce the required quality assurance specification. In other words, the third-party software development contractors must provide scientific evidence that they have supplied a solution with a cyber confidence of greater than or equal to 99% and a cyber risk of less than or equal to 1%. The third-party vendor must show scientific evidence that the probability of dormant defects remaining undetected is less than or equal to 1%. Let's now input our known boundary conditions as defined on the previous slide. The number of functional processes equals 10. The average number of user input commands per functional process is 5, where 1 user input command equals 1 dynamic information test. Please note that the default value of 0% risk quotient has been utilised. Next, we shall define our approach to testing. In typical commercial practice, particularly in the case of third-party vendors, we want to understand the so-called mission-critical minimum we need to deliver before we consider the broader picture. Hence, we select a calibration factor of 0.5, which denotes the design, construction and execution of critical priority tests only. Consequently, we determine that 67 critical priority test cases are required, which provides us with 80.22% cyber confidence. Moreover, by inspection of the graphical output, we can see that the risk mitigation is substantially greater than the risk exposure. That is, the lightly shaded area is significantly greater than the darkly shaded area, or in other words, the dimension alpha is significantly greater than dimension beta. Thus, we can expect the following composition of critical priority test cases. Half will be positive test cases, that is, half will test for success. Half will be negative test cases, that is, half will test for failure. Let's now have a look at the 99.97% cyber confidence solution. As stated by contractual boundary conditions, we are required to deliver a solution to the Martian Department of Defence satisfying 99.97% cyber confidence. Let's see what this looks like in the Testimator 1 GUI. Step 1. Input 10 functional processes. Step 2. Ensure that the default risk quotient value of 0% is selected. Step 3. Configure the dial for 5 dynamic information tests per test case. This is equivalent to an average number of 5 user input commands per functional process, as discussed previously. Step 4. Select a calibration factor of 2. This completes all inputs and yields the required contractual solution of 99.97% cyber confidence. To achieve this, 531 test cases will need to be designed, constructed and executed. All of these test cases must pass. That is, if even a single test case fails, then 99.97% cyber confidence cannot be delivered. Let's now consider the expected test case composition. The critical, high, moderate and low priority test case populations are split evenly at 25% each. We expect the body of work to comprise of 67 critical, high and moderate priority test cases each, as well as 65 low priority test cases. Moreover, we expect the number of super optimal test cases to be 265. All of this adds up to 531 test cases. So, what does the contractual solution look like side by side with the critical solution? Testimation technology has the capability of comparing and contrasting two quality assurance estimates simultaneously. On the left-hand side, you see the contractual test case solution, and on the right-hand side, you see the critical test case solution. The significant difference in area beneath the bell curves is quite stark. What is useful to know is that the ratio of test case solutions is 8:1. This means that the associated quality assurance effort and subsequent cost is also 8:1. Hence, a quality assurance manager only needs to understand the critical test case solution in order to size and cost the quality assurance associated with a project. This is important because it means that only a minimum amount of information is required to be gathered at the tender response stage of commercial engagement, rather than doing a deep dive into the tender and making a spectrum of assumptions in order to move forward with the tender response. We will discuss this more on the next slide. The risk associated with the test approach for the critical test case solution may be expressed exclusively in terms of the risk quotient, as appears emphasised by the purple box. The risk quotient does not represent solution cyber risk. It denotes the test approach risk specified by the user. This is useful because it allows the project team to identify the difference between solution cyber risk and the risk introduced by the test approach. In other words, it provides substance for a layer of accountability towards specific project team individuals. We will now circle back to discussing how knowledge of a critical test case solution enables quality assurance managers to size and cost any software project on the basis of cyber confidence and cyber risk. When sizing and costing a contractual prospect, depending upon the value of the contract, it may require substantial effort by a large project team. For example, if a contract is valued in millions of dollars, then the associated due diligence is substantially greater than a contract valued in thousands of dollars. In any case, due diligence is required, and it should always commence with critical information such as critical requirements and critical deliverables. This critical information leads to a critical solution. Hence, any methodology which can fast-track a tender response to a potential client due to minimal investigative effort is a valuable prize. In other words, the less effort a third-party vendor needs to expend in order to win business, all the better. The Decision Assistance Table demonstrates clear evidence of how knowledge of the critical priority test case solution, that is, Quality Assurance Solution 1, yields all subsequent quality assurance solutions. By inspection of the Decision Assistance Table, clients may specify whichever configuration of cyber confidence and cyber risk that they are willing to accept and absorb or have supplied by vendors. However, utilising the Decision Assistance Table, vendors are able to specify the level of cyber confidence and cyber risk that they can deliver over their competitors. In other words, utilising the Decision Assistance Table facilitates win-win situations for clients and vendors. The Test Case Constitution Table demonstrates to clients and vendors the breakdown of negative and positive test cases associated with each configuration of cyber confidence and cyber risk. An important fact that the Test Case Constitution Table communicates is that cyber risk tends to zero as the ratio of negative to positive test cases tends to infinity. In other words, cyber risk is minimised and software quality and reliability is maximised when the population of negative test cases is maximised. Thus, for software solutions requiring high reliability, for example military combat software, no less than a 3:1 negative to positive test case ratio should be utilised. Military clients should be prepared to spend a lot of money on software quality assurance. Let's now look at total project costing in detail. In this frame, we have executed a full project costing of our first simplified example. Assuming an average cost of designing, constructing and executing a test case equals $1,000 Australian, the decision assistance table demonstrates that the quality assurance spend required to deliver the contractual solution, that is Quality Assurance Solution 8, is $531,000 Australian. Appearing on screen is a software project composition statement. This is an empirical statement based upon approximately 3,000 international projects collected by one of the largest business consultancies in Europe. As you can see, the composition is based upon a 1/3, 1/3, 1/3 split. Despite the fact that this information is empirical, that is, it is actual project information which has been collected and analysed, it does have a theoretical foundation. The theoretical foundation may be explained by considering the following. Number one, the smallest possible commercial software project requires one developer, one quality assurance analyst and one project manager to manage everything and manage everyone. Number two, the developer can't be trusted to quality assure their own work, so a quality assurance analyst must be employed. That is, quality assurance must be an independent activity. Number three, if all three resources are dedicated to one specific project only, and they all start and finish the project on the same day, then their billable effort is equalised. Number four, this means that in this theoretical example, we have arrived at the same 1/3, 1/3, 1/3 split for software project composition, which is in agreement with the empirically collected data spanning approximately 3,000 international projects. Therefore, we have demonstrated that testimation technology, number one, predicts, measures and manages cyber risk, and number two, sizes and costs software projects. It has been an arduous journey, but this is the end of our first simplified example. Let's now move on to our second simplified example. The following fictitious dilemma is derived from real events. Dilemma: the National Bank of Mars is facing penalties of $1 trillion Australian due to software defects associated with their automatic teller machines. These defects resulted in criminal organisations depositing funds and laundering money in defiance of legislation and regulated banking practices. Investigation: the National Bank of Mars utilises testimation technology to conduct a software quality audit on the third-party software controlling their ATMs. The software quality audit measures that the vendor deployed their solution into production with a defect-free confidence, that is cyber confidence, of only 90%, without informing the National Bank of Mars of the residual 10% cyber risk. By comparing the results of the software quality audit to the decision assistance table, see slide 2, the National Bank of Mars concludes that the third-party vendor executed all critical priority test cases and approximately 62% of high priority test cases. This meant that 38% of high priority test cases and all moderate and low priority test cases remained unexecuted. National Bank of Mars analysis of the decision assistance table also reveals that the level of quality assurance deployed by the third-party vendor was suboptimal, that is, below 99% cyber confidence, possibly in an attempt to reduce project costs by prematurely terminating testing. The National Bank of Mars determined that the defect exploited by the criminal organisation had been categorised as a low priority test case by the third-party vendor. The National Bank of Mars concludes that if the third-party vendor had have tested to the economically optimal solution of 99% cyber confidence, the low-priority test case responsible for the exploited defect would have been detected and corrected prior to deployment. Resolution: since ATMs are independent third-party electromechanical devices, the National Bank of Mars could not have participated in the software development lifecycle or the software testing lifecycle of the deployed product. Consequently, the National Bank of Mars could not have contributed to the test case prioritisation process, which may have prevented the defect from being exploited by criminal organisations via the ATM user interface. If the low priority test case at the centre of the scandal had have been categorised as a critical priority test case by the third-party vendor, then it is conceivable that the defect would not have been exploited and the criminal organisation could not have laundered money. The National Bank of Mars argues in court that the third-party vendor should absorb 10% of the penalty costs due to an oversight in their test case prioritisation process. The court awards $100 billion Australian to the National Bank of Mars. Conclusion: testimation technology functions as an impartial scientific barometer for litigation purposes. The following fictitious dilemma is derived from real events. Dilemma. Martian Capital Investments is seeking to acquire Virgin Interplanetary Airlines following a downturn in travel due to a pandemic. Martian Capital Investments addresses its due diligence obligations by identifying key areas of scrutiny, one being cyber risk and associated remediation costs. Martian Capital Investments leadership is concerned about acquiring an information technology elephant and seeks to utilise the outcome of the cyber risk investigation in its negotiations with Virgin Interplanetary Airlines. Investigation. Martian Capital Investments utilises Testimation technology to conduct a cyber risk assessment of Virgin Interplanetary Airlines information technology systems. The cyber risk assessment measures that Virgin Interplanetary Airlines is commercially trading with a defect-free confidence, that is, cyber confidence, of only 80.22% and consequential cyber risk of 19.78%. Martian Capital Investments leadership is concerned by the risk exposure associated with this result. Martian Capital Investments analysis of the Decision Assistance Table, see slide 2, reveals that the level of quality assurance of existing Virgin Interplanetary Airlines information technology systems is suboptimal, that is, below 99% cyber confidence. Martian Capital Investments determines that the cost of cyber confidence remediation to the economically optimal solution of 99% requires a capital expenditure investment of 100 million Australian dollars. Resolution. Martian Capital Investments utilises their cyber due diligence as leverage in its negotiations with Virgin Interplanetary Airlines. Conclusion. Testimation technology functions as a potent cyber due diligence tool in corporate acquisitions. Dilemma. The United States of Mars is seeking to procure next-generation strike fighters for their war against the People's Republic of Venus. They have attended prototype demonstrations conducted by two major third-party vendors and are considering their tender responses. Given that both vendors are offering similar capabilities, the United States of Mars is exploring points of difference to assist with their final determination of preferred vendor for the $50 billion Australian procurement contract. Investigation. The United States of Mars utilises Testimation technology to conduct a cyber risk assessment of the avionics software aboard each prototype strike fighter. The cyber risk assessment measures that the prototype strike fighter associated with the Vendor 1 solution operates at 97.43% cyber confidence, whilst the Vendor 2 solution operates at 99.97% cyber confidence. United States of Mars analysis of the Decision Assistance Table, see slide 2, reveals that the quality assurance level of the Vendor 1 solution is suboptimal, that is, below 99% cyber confidence. In contrast, it also reveals that the quality assurance level of the Vendor 2 solution is superoptimal, that is, above 99% cyber confidence. The United States of Mars learns from Vendor 1 that to close the 2.54% software reliability gap between themselves and Vendor 2 would require a 6-month delivery delay. Resolution. After careful consideration of many factors including similarities, maintenance and life cycle requirements, the United States of Mars concludes that a decisive point of difference between vendors exists in relation to software reliability. The United States of Mars awards the procurement contract to Vendor 2 based upon cyber confidence. Conclusion. Testimation technology functions as a powerful decision-making tool in order to assess the cyber confidence delivery capabilities in a multi-vendor landscape. Testimation technology is the ideal solution to be applied in the cyber procurement assessment process. Okay, let's now summarise what we have learned. The key Testimation technology takeaways are as follows. In the first simplified example, we showed that, number 1, Testimation technology predicts, measures and manages cyber risk. It facilitates this by utilising statistical mechanics to convert empirical data into a probability distribution. Number 2, Testimation technology sizes and costs software projects. We demonstrated that by understanding the number of critical priority test cases which need to be designed, constructed and executed, then the entire project can be sized and costed. This is made possible by the 1/3, 1/3, 1/3 split rule, which has been empirically confirmed by a large European business consultancy, spanning a database of over 3,000 software projects. Number 3, Testimation technology minimises impacts of legal ambiguity in the context of undefined requirements via the generation of cyber confidence and cyber risk delivery specifications. Number 4. Testimation technology functions as a specifications generator of contractual requirements. It achieves this via cyber confidence and cyber risk predictions and measurements. In the second simplified example, we showed that number 5. Testimation technology functions as an impartial scientific barometer for litigation purposes. We demonstrated that the measurement of cyber confidence and cyber risk is a powerful tool by which to justify one's legal position. In the third simplified example, we showed that number 6, testimation technology functions as a potent cyber due diligence tool for corporate acquisitions. We demonstrated that the present quality status of corporate information technology systems may be exposed and the associated remediation costs placed on the acquisition negotiation table prior to contractual commitments. In the fourth simplified example, we showed that number 7, testimation technology functions as a powerful decision-making tool in order to assess the cyber confidence delivery capabilities in a multi-vendor landscape. Testimation technology is the ideal solution to be applied in the cyber procurement assessment process.